Welcome to the Hurrian Network, where we're connecting people through networking, and we're going to continue off from where we last left off. And that was this environment right here, right? We see the switch, we see the computers that are connected. We're able to remotely connect, right, with SSH, and we disable telnet, right? So we have a secure remote connection to the switch to access the command line if we ever have to, configure anything. Just check what's going on, verify everything's working well, right? And that's great. But now what I wanted to deal with in this case here is this. So when it comes to this environment, pardon me about that. So yeah, let's use this one here. So remember that I mentioned before in a previous video that when it comes to the switch, the thing is that when we just plug in a computer, it takes quite some time for the port of the switch to go up and for everything to work well, right? And this had to do with something known as spanning tree protocol, by the way. And that's basically a way for these switches to basically make sure that for any connection, because for example, let's say if a switch is connected to another switch, it'll check different states of the port for spanning tree to make sure that there is no switching loops. So if there's, like, let's say multiple connections between switches, the data is not just going to go around and round and round and round, because as we know with switches, by the way, they send something called broadcast messages, which means that a message will go out to every single port except for the source port where they got the data from, right? So in cases like that, that includes the switches that's connected to another switch, those ports as well too. And if they get that information and it goes back and forth and back and forth, if STP was ever disabled, it would bring the whole network down, and that would be bad, and we definitely do not want that, right? So that's great and all when you have a switch to switch, but in this case we don't have a switch to switch connection, right? We just only have PCs and laptops. And let's say that if somebody, restarted the whole system, right? The switch. They saved their configuration and everything, and someone accidentally restarted the switch. They clicked on the mode button on the switch, right? Let's just imagine that we're in a physical environment. As we see here, you see the ports, they're in a orange color, pardon me, because of the fact that it's going through that whole entire process I just talked to you about with spanning tree with the different ports. And those ports is a blocking, and then it's going to listen for something called BPDUs, which is sent between switches. Then it'll know, okay, spanning tree is involved based on that. It'll know if it's a switch based on that or if it's not, right? And then obviously in this case they're not going to get BPDUs because they're computers and laptops. But it took about 30 seconds for that to come up, approximately between 30 to 50 seconds around that area. And then it goes into a learning state, and then it's learning the MAC addresses of the devices. So it knows these MAC addresses and it records it in the CAM table as well, by the way. That's if there's any communication on the network, and it only keeps it in there for about 5 minutes. And then from there, after that, it's going to be in a forwarding state. And as you can see, they're all in a forwarding state. They're green links. That means they're up. They're good to go, right? But is there a way that we can just bypass all of this, right? So for these computers, so we don't have to wait that long every time for these links to go up? By the way, there is. And in spanning tree protocol, there's a feature for that, and that feature is known as PortFast, and you'd only do this only for ports that are computers and laptops connecting to the switch. Just keep that in mind. Or like servers, any endpoint devices. You would not do it between switch to switch. You would not do it for between a switch and a router or things like that. Anything where a lot of traffic is going to go through between devices, like between switches, like trunking ports they call it. In this case, access port, meaning that only one device is going to be read from that port, from the switch. Trunking port would mean that, for example, if you have a port, let's say you're connecting switches, you have something called VLANs, which I'll talk to you about in another video. When you want to have multiple VLANs to be able to communicate between one switch to another switch. But if you're quite confused about things and you still don't maybe get it, well, with PortFast, I'll show you how things will be set up and how we go about it, right? So let's use this laptop here, and let's go into the command prompt, and let's log in using SSH. So we're going to do SSH. And now it's asking me for the password, right? So now we're just going to see the running configuration, okay? Okay, so now we can see right here for these interfaces, we see spanning tree right here. Before I talk about the interfaces actually. So by default, spanning tree is enabled on these Cisco layer 2 switches 2960s. And this is enabled as well too. And this is for something called PVST, which is per VLAN spanning tree, which is basically having spanning tree for different VLANs. But we only have one VLAN by default, which is the default VLAN, VLAN 1, by the way, for this switch. So all these computers belong to VLAN 1, which is why they're all able to communicate with each other, because they're in the same network. And I don't want to go into more detail and more deeper into it right now, but the thing is that we're going to focus on is configuring PortFast, and we would configure it, by the way, on the interfaces that's necessary. So we can find out, okay, like which interfaces, you know, belong to, which devices belong to which interface, pardon me, on the switch interfaces, which ones they're connected to. So you know about show MAC address table. That's one command that we can use, but you see, this is the only one that it shows this is the laptop that I'm using right now as we speak, and it belongs to port Fast Ethernet 011. And then the other ones, there's no communication, so you'd have to go into every single one to find out which port it belongs to, then by using this. And it's dynamically learned, of course, right? It's not statically set. So that means that pretty much it learns this, and if this computer, this laptop, does not speak for about 5 minutes, it's going to go out of the table. So this is something we should keep in mind here. But from what I remembered, I used every single port. So like for example, PC0 is port 1. And this is 2, 3, 4, 5, 6, 7, and then 8 right here, I believe, and then 9, 10, 11. So we did the first 11 fast Ethernet ports to make sure that there was computers connected to it. So what we can do in this case is that we can see no interfaces have been configured yet, right? And what we're going to do here is this. We're going to go into interface, but we want to do multiple interfaces, so we don't want to just do one interface. If you want to do one interface, you can just go in like this and specify the interface. And this one I did fast Ethernet 0/1. But since I have 11 of them, I'm going to exit this and I'm going to go use this command right here. If you ever have a multiple range of interfaces you want to deal with, you do the command interface range, and then you can specify which one you want to do. And then you do a question mark, do a hyphen, right? And then I just did it from 1 to 11. And then we can look into the commands and see, okay, which command we're going to do. So we know that we have to do something related with spanning tree, now that I brought that up and talked about it, right? And we can see that there is, right here, the spanning tree command, right? So let's do that and see what happens. Okay, so there's different options here. There's BPDU guard, and remember I told you about BPDUs are between switches to make sure that, you know, they're able to basically know what's going on and set some specific conditions to find out. With spanning tree, there's something called a root bridge, which is like basically the king, who is the one that the traffic's going to go through as the main switch compared to the other switches, right? And cost, the cost has to deal with the interface cost. So there's specific conditions involved for all of this. And then there's guard right here, which is to change, it says the interface is spanning tree guard mode. So you can look into each and every one of them, the specific link type you want to specify for spanning tree. There is PortFast, which is the one that we're looking for, and then you see there's VLANs that you can specify for each VLAN, by the way, too. But what we're looking for right now is PortFast. So let's see what else we have to add here. So there's options of, this is the exact command right here, it's spanning-tree PortFast, what we're looking for, but we can see other options as well, such as disable PortFast for the interface, or you can even implement it on trunk mode as well too for PortFast, on interfaces in trunk mode, but that is not a best practice. You don't want to do that. You only want to do it on access ports. And then if I click enter, it tells you basically that warning that I explained to you regarding PortFast for all the interfaces here, saying that it should only be enabled on ports connected to a single host, which means it's an access port, by the way. Connecting any hubs, concentrators, switches, and bridges to this interface when PortFast is enabled, it will cause bridging loops. Because remember I told you, between those devices, if they're sending broadcasts and they keep sending broadcasts, it's called a broadcast storm, or a switching loop if it's between switches and go around and around and around, and the traffic will still keep on continuing and won't stop. It's going to take so much of the CPU of the switches and the power and all that stuff, and it's going to just bring the whole network down, and we don't want that. This is why you don't want to do this, and it's just giving you that warning. Okay, so now that we did that, we can actually exit, and then let's make sure that we save the configuration. Perfect. And then let me exit this. Alright, so we're going to exit this. Let's say we close that down, and let's say that we remove the connectivity of this port right here, right? For our laptop, let's say. And then let's say that we bring the cable back, and when we bring this cable back, we connect back to the same port we were in before. Boom. You see? It did not wait for a long time. It was not orange and waiting, going through each port state of STP to make sure it gets to the forwarding state. Now, we only applied PortFast from ports 1 to 11, which is for all these devices. We can even go back here again, right? 9, boom. You see? Instantly, right? And this one, it goes back to the port that was on, which was 10. Boom. Worked instantly. But let's say that I wanted to connect this device to number 12, for example. You see? Because we didn't configure PortFast on this interface, it's going through that whole entire states of STP, of the blocking, the listening, learning, the MAC address, then from there, and forwarding, which takes about between 30 to 50 seconds. So this is something that you should keep in mind when it comes to configuring a switch and having end devices connected to it, which is your PCs, your computers, your desktops, your laptops, your servers, printers, all these types of devices, right? So now it came up, but now let's put this back to the original port, and you see it came back fast. And that's the whole purpose of implementing PortFast. So then you do not have to wait for a long amount of time for every single device connecting to a switch. It makes things easier regarding that, but you do not want to enable it on any ports like a switch connecting to a hub, which we don't use no more obviously, but things like switch itself as well, routers, all these kind of devices, right? And that's all I wanted to tell you for today, and I hope you found some value in this video and you got some insight out of it. And for anybody that's been supportive, I appreciate it. Appreciate all the love. Comment, like, subscribe, all that good stuff. And if you like the content I'm putting out there, and you know other people that's intrigued about networking, let them know about it too and check it out. And let them see for themselves if it's something that will help them as well too. And until next time, take care.